Okay, we just have a few more examples, but as you can kind of guess, they're getting a little harder. So on this one, I'm going to think of this as tangent x to the 1/2. So I'm going to have to use, I got two functions. I have an inner function and an outer function, so I'm going to need to use the chain rule. So the derivative of tangent, and you might want to look and verify this, but the derivative of tangent is secant squared x. So we have y prime equals secant squared the square root of x. So that's the outside function, times the derivative of the inside function. So that's when it's helpful to think of it as the half power, because we're going to have 1/2 x to the negative 1/2. So I get secant squared square root of x over 2 square root of x. And that's our answer. By the way, I'm kind of going through these fast, so there is a slight possibility I could be making. I think have been good on these, but I'm sure someone will notice if I've made a mistake. So on this next one, y equals tangent 5x to the 1/2 power. Okay, you should recognize three functions. The innermost function is 5x, and then the layer out of that is the square root of 5x, and then the layer out of that, the outermost function, is tangent. So I'm going to start with the derivative of tangent, which is secant squared. So it's going to be secant squared square root of 5x. That's the outside function. Times the next level in is going to be the square root function. So it's going to be 1/2 5x to the negative 1/2. And then the innermost function, which is 5x, the derivative is 5. So when I simplify that, I'm going to have 5 secant squared square root of 5x over 2 square root of 5x. Okay, and hopefully you all remember I'm putting the square root of 5x in the denominator because it is a negative 1/2 on that. All right, next one. We have got here secant 2x plus 1, and that whole thing is raised to the third power. So that's what that secant cubed means. So I've got three functions. My outermost function is something to the third power. The one next layer in would be secant, and then the innermost would be 2x plus 1. So I'm going to start with the outermost. So I get 3 times secant 2x plus 1. But this time, when I reduce the power, it's squared. So I still have that there. Times, I need the derivative of secant. So if you take a look at that chart I gave you, the derivative of secant is secant x times tangent x. Or in this case, it's going to be secant 2x plus 1 times tangent 2x plus 1. I'm continuing on down here. And then now I need the derivative of the innermost, which is 2. So I get y prime equals, I can do 2 times 3, so we have 6 secant squared 2x plus 1 is the better way of writing this, times secant 2x plus 1. Oops, I see something else I could do then. Let's just make this cubed instead, tangent 2x plus 1. Okay, because this was squared and this was times another one of them, so we can just say secant cubed 2x plus 1. All right, on number 13, I'm going to use the product rule. I'm going to have to use the chain rule. So I'm going to think of u and v. So then u prime, the derivative of, now this is secant 3x, so my u prime is going to involve the chain rule. So u prime is going to be the derivative of secant is secant times tangent. So it's going to be secant 3x tangent 3x times the derivative of what's inside, which is a 3. Derivative of 3x, so I have a 3. And v prime, the derivative of tangent, is just secant squared. So I'm going to have secant squared 3x times the derivative of what's inside, which is a 3. Now I'm ready to do the product rule. So y prime equals, I have a 4 there, and it is u prime v, so 3 secant 3x tangent 3x, that's the u prime v, oops, plus u v prime. So we get, anything we can do here? Let's see, we have 3 secant 3x tangent squared 3x plus 3 secant cubed 3x. And I guess if we wanted to, we can pull that common 3 out and say we have 12 times secant 3x tangent squared 3x plus secant cubed 3x. Okay, so they're not hard, but you just got to keep everything straight. So once you've decided, okay, I have to use the product rule, but first I'm going to have to use the chain rule and some trig rules. I know that's a lot of rules to remember, but I have confidence in you. Okay, on the next one, we are going to use the product rule. So this is u, and this is v. So u prime, I don't think I'm going to gain anything by distributing, so that's what I'm not going to do that. I think I'm better off like it is. So u prime is cosine x, and v prime is 1, and then the derivative of this is negative sine x. So we get y prime equals u prime v plus u v prime. And let's simplify that and see if we get anything interesting. Not too much. I do have a cosine squared x minus a sine squared x. So if you remember, that was the same as cosine 2x plus x cosine x plus sine x. I was kind of hoping we would have had a sine squared x plus a cosine squared x, which would have been 1, but we didn't. But that's okay. And we're finally at the last one. So I'm going to rewrite this as cosine 2x to the 1/3 power. All right, so I'm going to have the chain rule. I have 3 different layers of functions here, so I'm going to be using the chain rule. So we have y prime equals 1/3 cosine 2x to the negative 2/3, that's the power rule, times the derivative of cosine is negative sine 2x, times the derivative of 2x, which is 2. So the 1/2 and the 2 cancel. I'm going to have a negative sine 2x over, and this is going to be the cube roots, and we're going to have cosine squared 2x. Okay, 2/3 power, 3 is the root, 2 is the power. Since it's negative, it's in the denominator. And that is our derivative, and that takes care of it. So what you're going to do now is the back page of that packet has 18 problems, so that's what you're working on. and we'll see what happens tomorrow. If we don't have school tomorrow, then I'll give you a break, and I won't give you anything new, but I will expect both of the assignments that you have had to be done.